Welcome to Chapter 7. Now we will learn how to predict a precipitate by comparing Q and KSP. Okay, when the question asks, will a precipitate form when lead nitrate is added to sodium chloride and then KSP is given, meaning that we are going to compare Q and KSP. Okay, that is the clue. Okay, and then another one, we have lead nitrate and also sodium chloride. So which salt should we focus on? Okay, look at the KSP, that is lead chloride. Okay, so the first thing that I will do is these two mixed together, they are added. Okay, so I will write down PbNO32 plus NaCl. I'm going to get PbCl2 and 2NaNO3. Remember to balance it. Okay, then after that, information given is the mole before mixing is mole for lead nitrate is 0.1 times 150. So I will get 0.015. Sodium chloride, I will get 0.2. 100, 1000, I will get 0.02. Okay, so this one refers to before it is mixed. Okay, so after they react, they will produce the salts that we are looking for. Okay, so what we do here is, if we want to calculate the Q, okay, if we want to calculate the Q, we know that we need to get the concentration for lead and also chloride ion. Okay, so where do we get these two concentration? Okay, so let's refer back to the reaction again. So Pb lead ion will come from lead nitrate. Okay, then chloride ion will come from sodium chloride. Okay, so now we can continue with our calculation. Okay, so first of all, write the reversible reaction equation for slightly soluble salt, that is PbCl2, lead 2 positive equals plus Cl minus 2 aqueous. Okay, then we straight go to equilibrium. Okay, we don't have to write equilibrium. Okay, this one is not, we don't write equilibrium, we just write concentration will do, initial. Okay, because we are comparing Q. Okay, so this is constant, then for lead, okay, just now we said find from lead nitrate, so we have 0.015 mole over, okay, the volume is 0.15 plus 0.1 liter. Okay, why? Because when two solution is added, PbNO3 and NaCl is added, we have 150 ml plus 100 ml, and then the solution inside contains PbCl2, our salt. Okay, so the volume has to be a total volume. Okay, then this one is 0.02, which comes from sodium chloride, 0.15, 0.1. Okay, so the answer will be 0.06 molar, 0.08 molar. Okay, now we calculate Q. Okay, for Q, write down the expression Pb2 plus Cl minus square. Okay, so substitute the value that we've got, 0.06, 0.08 square, and then we will get 3.84 times 10 to the power of negative 4. Okay, now let us compare Q and KSP. Okay, KSP is given 1.7 times 10 to the power of negative 5. Okay, so let's compare now. Q, I have 3.84 times 10 to the power of negative 4. Then solubility product given is 1.7 times 10 to the power of negative 5. Okay, so Q is larger or smaller or equals to KSP. Okay, of course, let's look at the value here. Negative 4 and negative 5 shows that Q is greater than quotient reaction is Q is greater than solubility product. Okay, meaning that we have more product compared to KSP. So it is a super saturated solution, and then PbCl2 precipitate will form. Okay, why do we answer this? Because remember the question asks, will a precipitate form? Okay, so after we have compared Q and KSP, then we mention what type of solution and whether the precipitate will form or not form. Okay, so for this type of question, okay, remember, find the number of mole for each ion, but the volume, it has to be a total volume because they mix, they react together, they mix together. Only then the salt is produced. And then if you want to know whether Q is bigger or smaller than KSP, substitute the value inside and then compare with KSP to find out whether precipitate will form or not form. Okay, that's all for this part.